Now we'll see the loss of amplitude over a cycle. So this is the spring mass system. This is the main position, and the mass M is as shown in the figure. K is the stiffness of the spring, and suppose you displace the mass by an amount of xa towards right and then release it. So initially the mass was over here, then it is displaced by an amount of xa. So this is the direction of motion, and now you release that particular mass. So it will cross the main position, will go on the other side. Suppose the other side displacement is xb, and then again it will go on this side and then again come back, and there is a reduction in the amplitude. So as you can see, xa is the amplitude or displacement. Then when it crosses the mean position, the friction will take place at these places, and because of that there is a reduction in the amplitude. The spring will get compressed. So there is a reduction or loss of amplitude over a cycle, and that particular loss of amplitude we have to calculate. So using the work energy principle, we can say that the strain energy will be equal to the frictional work. So strain energy of the spring is 1 half kx square. So xa was the initial displacement or amplitude minus 1 half x kxb square, as there is a reduction in the amplitude. Frictional work is defined as force into displacement. So total displacement will be xa plus xb. That is, xa is the displacement when it is moving towards right, and xb is the displacement when it is moving towards left. So total displacement is xa plus xb, and during that particular displacement the friction will take place. Now 1 half k you can take common from both these terms, so it is xa square minus xb square. So you can use the formula for a square minus b square, that is a plus b, a minus b. So xa plus xb will get cancelled from both the sides. So we can say that 1 half k xa minus xb will be equal to f. Now this is the value of f that we have obtained. Just rearrange the term. So cross multiply by these two over here, so 2f, and divide by k. K is multiplication, it will go on the other side, it will be in the division. So it is 2f upon k. So this is the loss of amplitude. Initially amplitude was xa, finally amplitude was xb. This was larger and this was smaller. So this is the change in amplitude or loss of amplitude for half of the cycle. The same will take place for the remaining cycle also. So for entire cycle you have to multiply this by 2, so it is 4f by k. So for complete cycle the loss of amplitude will be 4f upon k.